All right, in this video, we're going to go into the next part of notes 10 here, and this is going to be on solving fractional equations. So each one of these problems, 4, 5, and 6, has some fractions in it, and the thing is, we're going to get rid of those fractions. It's going to be a lot easier to work with. So how do we get rid of the fractions? Well, in problem number 4 here, I want us to find the least common multiple for 4 and 3. Now, if you know it off the top of your head, awesome. If you are unsure, off to the side here, you could list out multiples of 4. So that just means you're counting by 4. So 4, 8, 12, 16, 20. There goes some kind of motorcycle past my house. And I can do the same thing for 3. So 3, 6, 9, 12. Hey, I'm going to stop there. All right, the least common multiple of 4 and 3 is 12. So that's what we're going to use, okay, in our equation. So we're going to take each part of the equation, we're going to multiply it times 12. Now, I say multiply, but the reality is what we're going to do is divide by these denominators. So 12 here divided by 4 here. Well, let's see. 12 divided by 4 is just 3. Okay, and then I'm going to do the same thing here. 12 divided by that denominator. So 12 divided by 3 is 4. Now, there's no division here. Okay, no division because there's no fraction. There's no denominator there, right? None that I'm going to worry about. So let's see what we got here. Collect it all up. We've got the 3 here and then times 3k. So 3 times 3k plus 4 here times 2. So 4 times 2 and then equals the 12 times 2 here. So 12 times 2. That equation is what we're now going to solve. There's no more fractions. Love that. So distributing where we can, right? Multiplying here. I said distribute, it's actually just multiplication. So 9k plus 8 equals, I'm feeling 24 there. And then we do our inverses. So subtract 8 from both sides. So 9k equals 16. And last but not least, last inverse here to undo that multiplying by 9. We're going to divide by 9. And that's going to give me k equals, let's see, 16 divided by 9 is not going to divide nicely. I don't care about the mixed fraction, so don't bother. And 16 over 9 cannot be reduced. So we're just going to leave it as 16 over 9. All right, so that's problem number 4. Let's slide on over and talk about number 5 here. I'm going to approach it the exact same way. I want the least common multiple for 2 and 5. Again, if you know it, awesome. If you are unsure, however you can find least common multiple, something as simple as just listing out the multiples. So 2, 4, 6, 8, 10, 12, 14, you keep counting. 5, 10, hey, look, I'm just going to stop there because that 10 is in both lists. That becomes the least, the smallest number that they have in common as a multiple. So we're going to take each part of our problem, multiply with that least common multiple, LCM. And I always say, yes, I know I said multiply, but we're really going to divide. All right, so 10 divided by that 2. So that's going to leave me a 5 there. There's a little space. And then I'm going to do 10 divided by 5 here. That's going to be 2. Again, no division here. If there's no fraction, there's no division. Okay, so we have 5 times that whole numerator. Yes, it's important that it's in parentheses because that 5 has to get multiplied times both of those pieces. And then we're going to do 2 times, again, put the numerator in parentheses. 10 times 2 makes, 10 times 2 I wrote it out already as a multiplication. It's all good. All right, so distribute. So that's going to become 5x plus 20. Distribute again. So 2 here and 2 here. So that's going to be plus 2x minus 6 equals 20. And on this left side, I've got a couple of like terms that I want to combine up. So x's go with x's. Right? They each have a single x in them, so that's going to be 7x. And then the constants will go together. 20 minus 6 would be positive 14. Okay. And so now I'm going to keep going. All right, so we've got a single x on the left side. We've got to isolate that x. So I'm going to get rid of the 14, and then I'm going to get rid of the 7. So to get rid of a plus 14, whoops, right, minus 14. There we go, minus 14 on both sides. So 7x is equal to, what is that, 6? That is 6. And then if I divide both sides by 7, 6 over 7, I absolutely can't reduce it. I'm not going to do anything with it, so 6 over 7 it is. So there's all the bits, parts, and pieces for number 5. Okay, so let's see if we can do one more here for number 6. And number 6 is a little different than the first two because we're going to do a lot of the same stuff, but before I even want to talk about least common multiple and anything else, I have mixed fractions. I don't like mixed fractions. I've never liked mixed fractions. And especially in this situation, I don't want to work with mixed fractions. So I am going to take these mixed fractions and I'm going to turn them improper. So to turn an a mixed fraction to improper, we're going to take the whole number, multiply it times the denominator, okay, a little time sign here, and then I'm going to add that numerator. So 3 times 2 is 6, 6 plus 1, that's going to be 7 over 2p. Plus 2 equals, I'm going to do the same thing here, multiply. 5 times 3 is 15, plus 2 makes 17 over 3. Now that the fractions are in this improper format, now I can do the same thing I did in problem number 4 and in problem number 5. So least common multiple for 2 and 3. I happen to know that's 6, all right, so I'm just going to use the 6. Glitchy there. 6, 6, and 6 there. And I said we're going to multiply, but really we're going to do that division step first. So 6 divided by 2 makes 3. So 3 times 7p plus, do not divide this. All right, please be very careful. This is not a division step. That's just straight multiplication because there's no fraction there. There is, however, a fraction here. Okay, so that's where I am going to divide. 6 divided by 3, that makes it 2. So we've got 2 times 17. That's the equation that we're now going to solve. Okay, so multiplying across the entire thing here, we've got 3 times 7, so 21p. 6 times 2 is 12. 2 times 17, that's going to be 34. And let's solve for p. Okay, so subtracting 12 from both sides. So 21p equals, what's that going to be, 22. And then, oops, I don't need the color chart. Let's go ahead and divide both sides by 21, leaving me with a lovely improper fraction of 22 over 21. The fraction cannot be reduced. The fraction cannot be simplified. I definitely can't divide that. And I will never convert from improper to mixed. So I'm going to leave that as 22 over 21, and I'm a happy camper. As always, let me know if you have any questions or concerns, and come on back for the next one. We'll do the next part of the notes.